Before we start describing the Lewis structures as a way to describe covalent bond, it may be good to first understand what theories we have to describe the covalent bond, and also to understand that when we talk about ionic bond or covalent bond, what we're actually describing is two extreme cases. When you have a covalent bond or an ionic bond, it implies a different kind of sharing of electrons. When you have an ionic bond, and let's choose the least electronegative or one of the least electronegative in the periodic table with the most electronegative, cesium fluoride, this is an ionic bond. That's how we defined it. However, you have to admit that regardless of the difference of electronegativity, there will always be some sharing of electrons. So this means that even though we describe this as an ionic bond, there will always be a little bit of a sharing of electrons. So there's a lot of gray area between a purely ionic, this would be a purely ionic, which in practice will never exist, or down here, a purely covalent. A purely covalent, however, will exist when the two atoms are the same. So for example, when you have nitrogen for the molecule N2, in this case, because these two atoms attract the electrons in the bond in the same way, these bonds in the triple bond of nitrogen are truly 50-50% shared. Unless they are the same atom, all of the bonds will be found somewhere in the middle. Even cesium fluoride is not 100% ionic. We will talk about a polar covalent bond. That is, when you have two atoms that share an electron, depending on the difference in electronegativity or the difference in capturing the electrons being shared, it will be more or less polar. So how can we describe covalent bonds now that we know that most of them will be polar? So there are three different theories that we will talk about. The first two in this first semester, the Lewis structure that we will talk about today, then the VSEPR that we will talk about later, and molecular orbitals that we will talk about in another module. So let's first describe what is a Lewis structure. First of all, we are going to display a Lewis structure. We're going to describe the atom with dots representing the valence electrons. In this case, lithium has lost all of the valence electrons, therefore it has no dot around it because it has lost all of its valence electrons. Fluorine now becomes a fluoride. It has 8 valence electrons. This is why you can see in here 8 dots around it. So the ionic bond described in terms of Lewis structures does not share any electrons in between, because there's a net transfer of 1 electron from lithium to fluoride, so therefore there is no covalent bond that we could talk about. You will see a covalent bond when you actually have a sharing of electrons, such as in fluorine, in F2, you have a 2s2, 2p5, so you have to have 7 dots, 7 electrons around it. So 7 here, 7 here, these two will form a bond. So when you see this bar, that implies the same as 2 dots being shared. This is a single bond in which the 2 fluorines are sharing 1 electron each. So notice that both fluorines now have 8 electrons around them. So it will be 1, 2, 3, 4, 5, 6, 7, and because this one is shared, 2, 8. The same for fluorine. 1, 2, 3, 4, 5, 6, 7 again, and 8. Okay, so both of them follow what we call the octet rule. That means they will have a 2s2, 2p6, that is 2 plus 6, 8 electrons, noble gas configuration. So some nomenclature. We will call the bonding pair as the pair of electrons that are being actually shared, so between the atoms, and we will call the lone pairs as the electrons that do not participate in the bonding. So there are some rules to build a Lewis structure that we will follow more or less slowly, but we know that you have seen this before, so probably will not go as slow as someone who has seen this for the first time. So the first step to build a Lewis structure of a molecule is to identify the central atom, and the central atom will be the least electronegative. Being N the least electronegative, you will put N in the middle, and F you will distribute them around them. Okay? Now let's see how many electrons each of these should have. We know that nitrogen has 5 valence electrons, remember, it's 2s2, 2p3, and each fluorine has 7 valence electrons, 2s2, 2p5. Okay, so if you place them around them, you can have 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. That was fluorine. How can I put nitrogen? So I have 1 in here, 1 in here, 1 in here, and I'm already placing these here. So that's a little bit the distribution of electrons. I already placed them to see which one is going to be lone pairs and which ones are going to be the electrons being shared in the bond. So notice that because all of the elements belong to the second period, nitrogen and fluorine belong to the second period, so we want it to follow the octet, all of them. So we want 8 electrons each. This means that nitrogen, having 5, needs 3 more, which can gain from 1 fluorine, 2 fluorines, and 3 fluorines. So there you go. Now we have, this is what we will call a lone pair. Fluorine will have, and notice that now I'm kind of going faster. Instead of drawing 2 dots, I'm just drawing a bar. So this bar is equal to 2 dots. You may see both depending on how fast you want to write. All right. So this will be the Lewis structure of nitrogen fluoride.